Solo brothers and sisters, good morning to all. Today's topic is purification of salt. It is the continuation of surface chemistry. Purification of salt can be explained by the chemical method. Chemical method, first one, double decomposition. That is a H2S gas pass through the arsenic oxide and the formation of arsenic sulfide and the removal of water. This salt is a yellow salt. Now balance the equation. Here common is sulfur, 3 sulfur, here 1 sulfur, here 3 sulfur. So 3 times hydrogen is what? 6, oxygen is 3. This is a balance equation. Another second method, oxidation. Same H2S pass through the SO2 to formation of sulfur salt and water. Balance equation. Here common oxygen, 2 oxygen, here 1 oxygen 2 times, 4 hydrogen, here 4 hydrogen, common is sulfur, here 2 sulfur, here 1 sulfur, 3 sulfur. Another method, hydrolysis. Hydrolysis is nothing but ferric chloride boiled with water. That is a boiling water to form ferric hydroxide, that is a red salt, and the formation of HCl. Balance equation. Here common chlorine, 3 chlorine, here is what? Only 1 is a 3 times. Common hydrogen, here 3, here 3, 6 hydrogen is a 3 times 6 hydrogen. Common oxygen, 3 oxygen. These are the balance equation. Resulting salt, either red salt, sulfur salt, yellow salt, which containing the amount of electrolyte. Electrolyte nothing but either positive charge and negative charge, and small amount of impurities. This can be removed to obtain pure salt. This name is called purification of salt. Purification of salt can be explained by there are different types of method. First method, dialysis. Second method, electrodialysis. And third method, ultrafiltration. First method, dialysis. Dialysis. Second one, electrodialysis. Third one, ultrafiltration. How to explain one by one? First one, dialysis. Dialysis is a process by which removing ions or molecules from salt by diffusion through the semi-permeable membrane. This name is called dialysis. Dialysis explained by using the dialysis pack. This one fresh water inlet, this is outlet. This is known as dialysis pack. This is known as salt particles. This one molecules. This one electrolyte. The dialysis carried out by using the dialysis bag. These are the dialysis bag. It is made up of animal membranes or bladder or cellophane sheet. It pores very smaller. This dialysis bag is suspended in fresh water. When continuously supply the fresh water here, slowly diffuse the impurities like electrolyte, remaining salt particles present. This process known as a dialysis. Dialysis nothing but the process of removing ions or molecule from the salt by using the diffusion. This name is called dialysis. For the examples, dialysis used to removing HCl from ferric hydroxide. Here, see the equation. There is a hydrolysis equation. Is a ferric chloride react with the boiling water to form ferric hydroxide and HCl. HCl is a impurity. Here is a red salt. We have to remove the impurities. What impurity? HCl from the red salt. This name is called dialysis. This dialysis is a first one is by using the dialysis bag. Another one important point is artificial kidney machine. It is used to purification of blood of patients. These are the second point. Next method, electrodialysis. It is a slow process. The slow process can be enhanced by using the electrical field. This diagram used for explain the electrodialysis. Electrodialysis is a slow process. This process enhanced by applying the electric field. When electrical potential supply the across the metal screen supported by the membranes. This membrane used for speed up the movements of ion from the opposite electrode. For example, there is a positive ions and a negative ions present as a impure salt. Positive ion move towards the negative electrode, negative ion move towards the positive electrode. For example, Ag plus Cl minus. Ag plus move towards the opposite electrode, that is a cathode, is a negative. Cl minus ion move towards a positive electrode is anode. This method not applicable for the non-electrolyte impurities like sugar and urea. This process known as electrodialysis. Next method, ultrafiltration. Ultrafiltration is a process in which the separation of salt particles from liquid medium and electrolyte by filtration through the ultrafilter. This name is called ultrafiltration. It is a slow process. Here, when gas supply on the salt particles and the electrolyte, here electrolyte and water filtered after, remaining colloidal particles are present on the ultrafilter. Ultrafilter is made up of collodion. It's an ordinary filter paper. It's a porous very larger in which a colloidal particle easily pass through it. This its porous is impregnated by using the collodion. Collodion nothing but 4% nitroglycerin or nitrocellulose in the mixture of alcohol and ether. Its porous much reduced. The modified filter paper nothing but ultrafilter. Here, after this supplying the gas pressure, salt particles formed on the ultrafilter in the form of slime. This slime is stirred with another medium to obtain the pure salt. By using this method, different size of salt particles can be prepared. This process known as ultrafiltration. Ultrafiltration nothing but the separation of salt particles from the liquid medium and electrolyte by filtration through ultrafilter. This name is called ultrafiltration. This process known as dialysis, that is a purification of salt. Purification of salt can be explained by there are three methods: dialysis, electrodialysis, another one is ultrafiltration. Next, properties of salt. Properties of salt can be explained by there are different methods. First one, physical property. Second one, mechanical property. Third one, optical property. Fourth one, electrical property. There are four properties. How to explain one by one. First property, physical property. Physical property can be explained. There are different types. First one, heterogeneous nature. Second one, color. Third one, size of colloidal particles. Fourth one, filtration, that is a filterability. Fifth one, non-settling nature. Sixth one, divisibility. Seventh one, colligative properties. Eighth one, concentration and density. Ninth one, surface tension and viscosity. 10th one, shape of colloidal particles. There are different types of physical property. First one is a heterogeneous nature. Heterogeneous nothing but there are different phases. Second one, color of the colloidal particles. Third one is a size of the colloidal particle. Filterability. Next, non-setting nature, divisibility, colligative property, concentration and density, surface tension and viscosity. Last one, shape of colloidal particle. You have to discuss one by one. What is the first one? Heterogeneous nature. Colloidal particles of colloidal solution are the heterogeneous nature. This type of question may be asked in the 1 mark, both theory and NEET. There are two phases. First one, dispersed phase. Second one, dispersion medium. The combination of dispersed base and dispersion medium to form colloidal solution. The component by which small portion, the component by which larger portion. Larger portion nothing but a dispersion medium, small portion nothing but a dispersion phase. Here, substance distributed as a particle. Here, colloidal particle is a dispersed. the combination of dispersion base and dispersion medium to form colloidal solution. For example, there is a dispersion base liquid, dispersion medium gas, this name liquid aerosol. Best example, cloud, mist, fog. These are the example. This colloidal solution what nature? Heterogeneous nature. Maybe ask the 1 mark questions. Second one, color. Color of colloidal particles of colloidal solution depends on point number 1, methods of preparation, point number 2, wavelength of sources of light, third one, size and shape of colloidal particle. Last one, observed views. Observed views, either reflected light or transmitted light. These are the factor depends upon the colors of colloidal particles. Another one, filterability. Here, ordinary filter paper is a porous, very larger, in which a colloidal particle easily pass through it. This name is called filterability. Next, non-setting nature. Colloidal particle is a greater affinity with is a stability. It is not affected by the gravity. This name is called non-setting nature. Another one, diffusibility. Colloidal solution of colloidal solution at a very slow rate. Best example, gelatin, starch, glue. These are the best example for diffusibility. Is another one, colligative properties. Colligative property depends upon the number of particles present in the solution, that is a colloidal particle. Colligative properties are relative lowering of vapor pressure, second one, elevation of boiling point, third one, depression of freezing point, fourth one, osmotic pressure. In the osmotic pressure, it is used to measure the molecular weight of colloidal particle. This explained by the colligative properties. Another one, concentration and density. Here, colloidal particles of colloidal solution is diluted. Here, density is decreases as well as concentration also decreases. Both are decreases. This explained by the concentration and density. Another physical property, surface tension and viscosity. Surface tension and viscosity explained by there are two factors. First one is lyobobic, that is a solvent heating. Another one lyophilic, solvent loving. What is the meaning for lyobobic? Colloidal solution in which dispersion base and dispersion medium are less affinity or considerable affinity. This name is called lyobobic. Best example, sulfur in water. Another one is lyophilic, solvent loving. Now, colloidal solution in which dispersion base and dispersion medium, there is a minimum affinity, that is a considerable affinity. This name is called lyophilic salt. Best example, gelatin, starch, etc. Here, surface tension and viscosity, not much difference in lyobobic in dispersion medium. Another one, surface tension and viscosity explained by the lyophilic. It is not the same. This word different. Here, viscosity increases, surface tension decreases. This is inversely proportional. Lyobobic and lyophilic explained by there are two factors, surface tension and viscosity. Lyobobic nothing but colloidal solution in which dispersion base and dispersion medium are less affinity or affinity will be negligible. Lyophilic salt, the colloidal solution in which dispersion base and dispersion medium are considerable affinity. This one best example, sulfur in water. This one best example, gelatin and starch. Here, surface tension and viscosity not different much in the dispersion medium. Here, viscosity increases as well as surface tension decreases. Next point, shape of colloidal particles. Colloidal particles of colloidal solution depends upon the shape. That is colloidal particles shape. First one, AS2, S3, so shape is spherical. Second one, FeOH, thrice, that is a ferric hydroxide salt, blue gold salt, the shape disc or plate-like. Another one, W3O5, that is a tungstic acid salt. The shape is rod-like. These are the shape of colloidal particle. First one, arsenic sulfide is a spherical shape. Ferric hydroxide, blue gold salt, the disc or plate-like shape. V3O5 is a tungstic acid salt, it's a rod-like shape. This is known as a shape of the colloidal particles. All are physical property. Physical properties are heterogeneous nature, color, size, filterability, non-setting nature, divisibility, colligative property, concentration and density, surface tension and viscosity, shape of the colloidal particle. Next, explained by the another property, mechanical property. Mechanical property, another one is a kinetic property. Colloidal particles of colloidal solution can be viewed through the ultra microscope. It constant rapid motion. For example, these are colloidal particles. This is known as dispersion medium. Colloidal particles of colloidal solution viewed by using the ultra microscope. It is a constant rapid motion. The continuous rapid zigzag static random motion and ceaseless motion executed by the colloidal particle in the dispersion medium, this name is called Brownian movement. Here what is that? Colloidal particles of colloidal solution viewed by using the ultra microscope. It is a constant rapid motion first absorbed by the rapid Brownian. This name is called Brownian movement. Here continuous rapid chaotic random and ceaseless movement executed by the colloidal particle in the dispersion medium. This name is called Brownian movement. This due to unbalanced bombardment of molecule by the molecules of dispersion medium. This name is called mechanical property. Here size of colloidal particles depends upon the nature. If the particle size is smaller, less viscosity, faster the Brownian moment. If the solid particle is a very larger, is a highest viscosity, the Brownian moment is very low. So size of the particles depends upon the Brownian moment. Another one, Brownian moment able to calculate or to find Avogadro's number. You know that equal volume of all gases under the condition of same temperature and pressure which containing the equal number of molecules. This is known as a Avogadro number. Is a Brownian moment able to calculate or find the Avogadro number? Point number 2. To confirm kinetic theory. Here, Brownian movement depends upon the size of the particle. If the size of particle is smaller, lesser the viscosity, Brownian movement will be faster. This is explained by the kinetic theory. Another third one, to calculate stability of colloidal particle. These are the important point to calculate these are the factor. Brownian moment able to find the Avogadro number, kinetic theory. Another one is stability of colloidal particles. Next property, optical property. Optical property, another name called as Tyndall effect. This one, true solution. This one, colloidal solution. So true solution, best example, salt or sugar in water. It's a diameter 1 Armstrong to 10 Armstrong. Size of the colloidal particle is a range in diameter 10 Armstrong to 2000 Armstrong. This is a colloidal particle. Here this is known as beam of light. Here beam of light not visible. This is a beam of light visible. Is a optical property, that is a Tyndall effect, can be explained by there are two factors. First one is a true solution, another one is a colloidal solution. True solution is a best example, sugar in water or salt in water. It's a diameter 1 Armstrong to 10 Armstrong. Is a colloidal solution is a best example, milk powder in water. There is a diameter 10 Armstrong to 2000 Armstrong. When beam of light pass through the different solution, that is a true solution and a colloidal solution at a right angle. Here beam of light is not absorbed. Here beam of light absorbed. Why? Because that is colloidal particles absorb the light energy and emit in all direction. That is the phenomenon by which scattering of light by the colloidal particle. This name is called Tyndall effect. Let us recap the purification of salt. Purification of salt can be explained by there are different factors. First one, dialysis, another one, electrodialysis, another one, ultrafiltration. Second one is a physical property. There are different type of physical property. That is first one, heterogeneous nature. Another one is color of the colloidal particle. Next is size of the colloidal particle. Size of the colloidal particle is a range 10 Armstrong to 2000 Armstrong. Next, filterability, non-setting nature. Another one is divisibility, colligative property, concentration and density, surface tension and viscosity, and shape of the colloidal particle. These are the physical property. Another one is a mechanical property. Mechanical property is a Brownian movement. The Brownian movement in which the continuous rapid zigzag, eclectic and ceaseless movement executed by the colloidal particles. This name is called Brownian movement. Brownian movement depends upon the size of the particle. If the size of the particle is very smaller, less viscosity, Brownian movement will be faster. Another one is optical property. Optical property is what? Tyndall effect. Tyndall effect by which the phenomenon by which scattering of light by the colloidal particle. This name is called Tyndall effect. This topic, dialysis, Brownian moment and Tyndall effect, very important. By using this concept, one more question may be asked. How to practice all the types of concept and get highest mark. Good luck.